Hello everyone, this video is about MechitCalc, the piping calculation software that I made. I'm going to show you how to use it and also some of its features. In the top here you have the three different buttons for the different calculators and also the extra utilities. We'll start off with the standard EN calculation. The general flow of every calculation is pretty much the same. You have the main information on the left and then you have the selectors or extra information on the right. So we'll start with the calculation input. First we have material, which you can select using the select material field. You can go through the different materials here, and probably the easiest way to do this is of course to just search the material. You don't have to be very super specific with the search, you just have to search for the different parts of whatever material you're using. So in my case I want to use 304L stainless steel according to the SME code. So I'll just go for 3112, which is piping, and then 304L. We'll press enter to search, and then I can see all these different versions, and it will also show you the different type it is. So for example, you have increased design stress or just a standard one, and you also have, which is from the SME section 2D, the design stress functions that have a different joint efficiency. For every especially for SME materials, for every part that has a design stress, there will be a different material listed here. But if you are using it for EN, like in this case, then of course the design stress from the SME is not going to be used. It's going to calculate it again using the yield design stress. So in that case, there's not going to be a difference between any of these because they all have the same yield stress. For now, we'll just take the normal 304L. There's also this button for extra descriptions. These are the descriptions from the table that say something about its product form or applicability, or also the product, different product form types. And because it's SME material, it will have the notes, of course, and it will also have the different applicability sections. We've selected the material, and it's also shown here. We can close this. It will also show it here. You can also clear the material here. You don't really have to do that. You can just select a different material and it will select that material. Next step is design stress. This is the design stress method that is being used on top of the design code. And this is a straight pipe EN design code, so it will use EN 13480. And then you have an optional way of using a different design stress. Very often when you, for example, if you're using something in a ship, then you would use a standard design code, but then it's adjusted with usually a slightly lower design stress, just so that it's a little bit safer for the ship building. We'll go for 1.8, which is a very general one for LNG things and things like that. Then we have the pressure and temperature cases. We can calculate multiple cases, and it will calculate all of them at once. So you can have lots of cases or you can just have one or two. And the nice thing about this program is that it doesn't really take a lot of extra effort. I need a different temperature and pressure combination. We can just add it here and it will add it to the calculation. It's as easy as that. So this is a megapascal, so if I have 10 bar, it's 1 megapascal, and then 100 degrees Celsius. And then maybe we have a higher temperature, like this. And maybe we have something at room temperature or 50 degrees Celsius. So now we have our temperature and pressure cases. Then we have the tolerance. This is a very expensive feature. Well, expensive. It's a feature that I really always wanted to have in different calculation programs. Normally you just have the tolerance in percentages. So normally for SME piping it would be 12.5%. But it also allows you to use these dual ones, which is sometimes the case for specific piping material. If I do 10% and then 0.1 millimeters, what it will do is it will take the highest of these two based on the thickness. So this is going to be 10% of the thickness or 0.2 millimeters, which means if 10% of the thickness is more than 0.2, then it will take 10% and else it will take 0.2. You can also just put in straight millimeters, or you can select a preset. These are specific presets from different codes, especially these EN216 ones. They are presets specifically that change depending on which size you're in. So it's kind of complicated, but that's why it's a preset here. I just have to set this one, and then it will use whatever tolerance this code requires. And we can see that later. Next part is joint efficiency. So let's say it's welded piping, so we'll put 0.85. And if corrosion allowance for stainless steel, that would normally not really be required. But I'll set it at 0.1, just so you have an idea. This is in millimeters. Now you have stress design override. This means that if you want to calculate it yourself, maybe the material is not available in the general calculation software in the database, then you can calculate your own design stress and then you fill it in here and it will use that. And if you do that, you don't have to fill in the material. But if you don't fill it in, then you have to put in the material. We'll leave this empty because we've already set the material. And then the last step is going to be selecting our pipes, which uses this pipe selector. And I've made it so that you can very easily select all the pipes that you need based on standard schedules. I'll expand on more schedules later, so these are the basic ones. What you can do is you can select everything, or you can filter this list. Normally, how to select it is you can just click each thickness and it will add this to the calculation. Let's say I just have schedule 40S, then I can click this filter, so it will only show the schedule 40S ones. And then you can just click the ones that you really need right now. And what you can also do is you can select this and then it will show, instead of the diameter in millimeters, it will show you the inches. It's all personal preference. And then there's also a button to add custom pipes. So if you have something doesn't fit here, you can add a couple, or you can also remove them using this button. And then let's say it's a special 100 millimeter pipe, that's 2.3 millimeters, and you can do this, and then maybe this is the 100, and this is 4-inch. That's not. So these are like the metric pipes. You can add them very easily like this. So we've selected our pipes, and that means that we are actually good to go for the calculation. We've already set up our whole calculation. So we can press calculate, and it will calculate it. And then in the bottom here you have all your different cases, and you have an extra documentation tab. So we'll start with this one. It will show you a table with all of the values, in between values, input values, and then also the output. And it will also show you the code compliance and utilization, so how much is actually being used and how safe are we. It will also go, if it's not compliant, then it will show you how much you're out of bounds or over our design stress, for that's in this case. So it shows you the design stress here, it shows you the absolute tolerance here, so 0.4 millimeters, 0.69 millimeters. And this is then based, of course, on the calculation, on the selection that we did. So this is the EN216CS. If I would change this to 12.5% and calculate it again, then it will give you, I think most of these are the same, but that's because I think around these sizes it will, I think the EN216 also has part of the sizes at 12.5%. You can look through all of your numbers here. You can also search for a specific one, and then it will show you those. You can also, I think, search for EN32. Yeah. And if there's too much values here, you can also just remove some of these, just to make it a little bit easier to read. Change these columns. Now, the nice thing about this program is the documentation that's built in. So I can just select a calculation like this one, and then it will show you all the steps that are used to get that calculation. So then it has thickness, design stress, minimum thickness, and it also explains it to you, and also has the actual formulas that are being used inside of it. So this makes it really easy to just hand calculate, check stuff. You should always check stuff as an engineer, a piping engineer that does calculations. That's what I believe. I want to be able to check everything, and then maybe at the end of when I build a pipe spec, I'll just do some hand calculation, check if everything is correct. And sometimes I'll also do verification. I also do my own verifications in the program, but it's always good to check afterwards, because there can be some weird things pop up, or some things that you didn't really think of when you put in the information. This allows you to check all of that, and for each calculation. Another thing I didn't really look at, and that's something, for example, if I take a different design stress, then yeah. So there's also a column called calc1. This is extra notices or warnings or things like that. So this is numbered, and then in the bottom here it will show you the extra warnings or things that you have to check. So in this case, this calculation uses the RP 1%, but because it's an SME material, you don't have those increased, those 1% strain numbers. So to calculate it with that anyway, you'll take the RP 0.2% instead, which is for SME there's no difference in yield strength. It's only the EN thing. For SME it's just always just the yield strength. And then there's some other weird stuff that how SME handles the low yield stress for stainless steels, but we're not gonna talk about that. But it comes back as a warning here. And if I, for example, take a very high pressure, let's say 90 bar, all right, yeah, this design stress is not very suitable for that. Let's go higher pressure. These pipes are not big, so it's not going to be. All right, I have to actually go to the right one. So here you can see that if it fails, then it will show up in red. Let's go back to another one. So 90 bar. Yeah. I think I turned off code compliance, right? So it will show you the code compliance, so it will turn yellow if it's close to 100, and then if it goes over, then it's non-compliant. And then also an option is you can create a report. And this is then the output of that report. So this is the selected material with the information. And then these same steps that we've watched before. So we'll go through all the same steps on the first calculation, and then all the other calculations combined will show up in a table form here. And then each case will have its own table. So we have 6 calculations 3 times, and it only takes 2 pages to show all the information. But it's in a way that we can actually very easily check the results of that. We can look at these numbers and then just do a hand calculation with this and see, all right, how does that work? What's really happening, and continue on with that. So this is just an internal straight pipe calculation, but there are also other calculations. So for example, a branch pipe, and also external pressure. These all, as you can see, they all kind of work the same way, but there's some more information to fill in, or different information to fill in, of course. For branch pipe, of course, you also have pipe combinations. So if I have a couple of pipes, then I then need to select combinations of pipe. And I can also select multiple materials. So that it kind of speaks for itself once you do each calculation. And then also each calculation has its own documentation. And the documentation will explain a little bit on what is actually happening and what you have to fill in to these values. So about tolerances or other things. And that allows you to very quickly make your calculation, and also to give you confidence about the calculation itself. There's some extra tools here, like material infill. This is if you do your own calculation, you can select a material, and then it will give you all of the information on that material. And then it also allows you to generate a design stress, to doing your own hand calculations. and it will show the full data for that as well. So design stress here is 85.55, 56. You can then use this for your own calculations. This is what I really like, because I still like doing my own calculations. And then the last bit is, if you do a calculation, you can also load your calculation. So this is a calculation that I did before. I can just load it. Then once you save the calculation, you also have some extra information to fill in. And then maybe once you get back, maybe the client comes back, maybe there's like a slightly different pressure, or maybe they're going to use a slightly changed thickness. Maybe just schedule 40 has become schedule 10. It's a simple change, just change it and then calculate it again, and you have your new results again. This is really a smooth way of performing these calculations, and also to just get back into it. I don't like having software where you have to go into all of the help documentation just to figure out, well, what do I really put into this here? Instead of that, the information is all available on the same page directly. Take a quick look at it, and then you can continue on. Thanks for listening and watching, and if you have any questions or maybe want to try out the program, you can always contact me. In the comments below you can do it. There's also a link to my website, and I'll also show my email address in the bottom here. So you can send me an email, you can send me a message. We'll go through it and I'll answer any of your questions. Thank you.